In this video, we're going to discuss a basic review of an OIP HPT log. In this log that I'm showing, the first graph is electrical conductivity, which is measured by applying a small current through the soil. And the lower portion of this, from 35 to 50 feet, is your sands, where we typically have low conductivity, sands and gravels. As the grain size is reduced, silts and clays, you're going to see increasingly higher conductivity typically. The second graph is our HPT, or hydraulic profiling pressure. This is a measurement of the pressure it takes to inject a set flow of water into the formation. And as you'd expect, sands and gravels also see very low pressure because they have higher permeability. And as the grain size is reduced, it decreases permeability, increases the pressure it takes to inject in those formations. The third graph is our percent area fluorescence from the OIP. In this sensor, we have a UV and a visible LED that's shining out a sapphire window. When it comes in contact with NAPL level fuels or oils, we'll see fluorescence. And in the probe, we also have a camera that's taking pictures as we advance the tool. And that's what we're going to take a look at now. I can click on near the top of this graph, and you see the green line up there, which is going to correspond to the depth and the captured image. As I press the down arrow key, you see the depth is increasing, and that's changing the captured picture that we're displaying in the image on the right. And these are all the saved images. We save 20 images per foot as we advance the tool. So when we get down near some fuel in this area, you're going to start to see some probably blue colors, blue-green colors, and that's what is very common for fuel and oils to display under the UV light. Now this is the actual image that was taken as we advance the tool. The analyzed image is what the software is looking at, and it's looking for the color that we see in the captured image. And it's telling us, based on set filters that are in the software, how many pixels within the image area are displaying that fluorescence. In this particular spot, this corresponds to 50% area fluorescence. And as we go through the fuel and we come out of it, we're going to see less and less until we get back down to basically just a black image. And it's going to be along those lines throughout the rest of this log. The red dots in the right side column are the depths at which UV and visible still images were taken as the probe was advanced. Many of them are taken when we add a rod, so the probe is stopped and the software automatically shifts between the visible light source and the UV light source and takes still images. And if I press the shift key and the down arrow, it will jump between the different UV stills. Now there's a tiny bit of fluorescence in that one. I unfortunately didn't get one in the main heart of that fuel, but we can sift through those. And then if I come back up here, the right arrow on the dot, it's going to shift from the UV still to the visible still, and I can shift and down arrow and jump between the different visible images. And you're going to see there's different colors of soil as well as texture, so it's very useful to be able to monitor what the soil looks like in those instances. Also, at times, if you're in a very coarse saturated sand where your fluorescence is, you can sometimes actually see NAPL globules in the visible images. Since this is also an HPT log, I want to go through taking a look at the dissipation test and look where our static water level is. So I'm going to left click my mouse on the view and open up the dissipation test. If you've already gone through the dissipation test and you've saved one, you could load that up, but I'm not going to, so I can go through this process. This is the saved time file for the dissipation, and this is our atmospheric pressure plus injection and any piezometric head. So when we stop the probe, we're going to shut off our HPT injection pump. That will dissipate off our injection pressure, and I'm going to come down to a spot near the end of this where the pressure has stabilized. I'm going to right click the mouse and set as a piezometric pressure at that point. Now I'm going to just minimize these right now. I'm going to come onto my HPT pressure graph. I'm going to right-click anywhere on the graph, go to my secondary series, and load absolute piezometric pressure. This is where the dissipation test was performed, where the filled-in triangle is. And then we subtract the pressure of water until we intersect atmospheric pressure, which was calculated in a pre-log reference test. This is where our static water level should be if you're fully dissipated. Here you can see we've got the static water level. That's where our contaminants are present. In this case, we have the fuel located in a permeable zone in the sands. You'd also be able to tell if they're in a stored zone amongst the silts or clays. So you'd know how to be able to treat those contaminants properly in remediation efforts. And at this point, let's go up and we're going to print a PDF view of this log. Here is how the log is going to print out based on our single log view setup in DI Viewer. The green line that we show there is the depth of the one image that's shown here. That's the captured image on the top, and that's the depth that it came from, and the analyzed image below. So that concludes this video. Thank you for watching.